Hello, we're going to have a look at solving quadratic equations just now. Before we get on to solving the equations, I just want to check a wee bit of understanding of some of the things about quadratic theory, quadratic functions. So I've got on the screen here a picture of some quadratic functions. We know that if we were to think about any function, a quadratic expression or a quadratic function, of course, looks a bit like this. Y equals, I have an x squared term. It might look something like x squared plus 3x plus 2. Okay, now that's a quadratic function because quadra in Latin means square, and it's got a squared term. Previously you might have worked on functions just y equals 3x plus 2, which would be a linear function, but the x squared term is a bit of a game changer because when you start to plot, if you for any value of x, if you work out the value of corresponding value of y and you plot them on a graph, you end up with this quadratic or parabola shape. A parabola is just that curve that it makes, and it might be a curve that goes down and goes back up, or it might be a curve that goes up and goes back down, and that really depends on the sign of the x squared term. So if the x squared term is positive, you're going to get a curve that looks like that, and if you end up with a quadratic function that's maybe got a negative, we even stick it at the beginning, if it was negative x squared plus 3x plus 2, then the negative sign would make it look a bit like that with a what we call maximum turning point. So that's how they look. And a couple of things that we want to remember on the screen here. The place where the curve cuts the x-axis is called the root, or a root of it. And the really important thing, that's what we're going to work on just now, is that the reason why it's called a root is that any of these points here, the y-coordinate is 0. That's the y-coordinate on the x-axis is 0. So that might be the point negative 4, 0. And that might be the point 3, 0, but you notice that in all cases the y coordinate is 0, y equals 0. Okay, and they're really important points in a quadratic function. A couple of other things, of course, you've got things like this idea of a maximum turning point. Oops, I'll get some of that. I should have. If I do that, a maximum turning point is simply where it comes to a head. So it goes up there and it comes to the top, a maximum point, and then it turns and goes back down. The minimum turning point is the one over here, where it goes down to the minimum and then goes back up. So these are some of the other terms. And if you notice at the end here, I've put one. And the important thing about this last, the blue curve, is that it doesn't cut the x-axis at all. In other words, this function has no real roots. It's got, we use the word real, we'll come back to that. It's got no intersection with the x-axis. There's no point on this curve where y is equal to 0. Okay, so we're going to come back to the idea of a root or roots of a function, and that's the points where the y coordinate is 0. The second thing you need to remember about to do this stuff is about factorising. There are 3 types of factorising. The first is common factors. So just remind you that we're looking to split this sum of terms into a product of terms. We're looking to introduce a multiplication feature in it, and so in this case here there's an x term in both of them. So we're looking for a common factor of x. There's no number factor, so we just take x as our factor, and then we introduce our bracket, which is multiplied by. We look at the first term, which is 2x squared. So x times what gives you 2x squared? X multiplied by 2x would be 2x squared. And then x times what would give you 5x, or would give us 5. So if we have the x multiplied by 2x plus 5, if I multiply that out, I've got 2x squared plus 5x. That is the factorized form. Okay. Second one is a difference of 2 squares. It's got 2 squared terms, a square number, a squared term, and a minus sign between, which is the difference part. And that's got a special way of factorizing. We have, we're going to have 2 terms in brackets, and the first term in each one is the square root of the x squared, which is just x, and the second term is the square root of the number 16, which is 4. And in order to make this x squared minus 16, we have to make one of the signs a plus and one of the signs a minus. I'm just going over this quickly. Hopefully you've studied this before, but that's us factorized it in terms of a difference of two squares. If we multiply out those brackets, we'll end up with the answer x squared plus 16. And lastly, we've got this trinomial factorizing idea. There's various ways to factorize. So we're looking for, again, we're going to end up with a pair of terms here multiplying, and depending on your method, you might say, okay, we want to have a multiplication and a plus sign. So if you multiply the coefficient of the x squared is 1, and you do 1 times 6, multiply the two n terms, 1 times 6 is 6, and then you write down the plus 5x, just as in 5. What we're looking for are factors of 6 that add up to 5. So we think of factors of 6, that's 1 and 6, or 2 and 3. Which pair add up to 5? Well, 2 and 3 add up to 5. Now, there's an extra step that we have to go if that number there is not a 1. And we're going to split up that 5x. But at the moment, if that's a 1x squared, then the good news is that we're just going to use that plus 2 and plus 3. Because our first term is going to be x and x, because x times x is x squared, and we put our plus 2 in here, and we put our plus 3 in here. It doesn't matter which order they go in, but the two factors that you've got of 6 that add together to give you 5 are our two numbers in the brackets. So hopefully you remember doing this factorizing. We're going to need it now, because I'm going to go on to actually solving the equation. So let's go on to our first example here. So we're going to solve a quadratic equation, and I don't like to do it in isolation. What's the point of a quadratic equation? Well, we're going to actually say find the roots of the function y equals x squared minus 1x minus 6. And I remember the wee yellow box, for any quadratic function the roots exist. We've just talked about that when y equals 0. There's the root there. Now if you've got a picture of the graph, the answer's already there. The roots of the function are x equals negative 2 and x equals positive 3. Okay, but we don't usually have a picture, but I want just to show you the answer before we work it out in a different way. So it says find the roots of the function y equals x squared minus x minus 6. What we know is that the roots exist when, well, okay, when x squared minus x minus 6 equals 0, because the y term is 0, the y number is 0 at both of these points. Okay, but we, instead of putting the 0 at the beginning, we stick it at the end, and here's our quadratic equation. Okay, so the way we solve a quadratic equation is this: we take whatever we've got on the left hand side, you notice that it's always equal to 0, and we factorize this. So x squared minus 1x minus 6 is a trinomial expression, and so we're going to factorize it in whatever way you know how. We know that we're going to have two brackets, like that. And we've got 1x times negative 6, it gives us negative 6. And then the number in the middle here is negative 1x, remember that's a 1, so we've got negative 1. So we're looking for numbers that are factors of negative 6, numbers that multiply to negative 6 that add together to give us negative 1. Let's have a quick think about that. So factors of 6 are 1 and 6, or 2 and 3. But importantly, it's a negative, so we've got to stick a 1 negative sign in front of the 1 or the 6 or the 2 or the 3. Okay, so it might be negative 1 and 6 or 1 and negative 6. But which one gives us a sum of negative 1? Well, if they're only 1 apart, it suggests that the 2 and the 3 are our answer. Do I put in, is it negative 2 and 3 or 2 and negative 3? Well, it would have to be 2 and negative 3. Would give us a sum of negative 1. So there are our two numbers here. We're going to use positive 2 and negative 3. Because it's only a 1x squared term, we can go ahead and actually put those numbers in our brackets. We start off with x and x. We've got positive 2 and we've got negative 3. Okay, so we've factorized the expression, but this time it's equal to 0. So what we're saying is that two numbers multiply together to give us 0. What two numbers multiply together to give you 0? Well, if you know, if I tell you I'm thinking of two numbers and the product is 0, one of them has to be 0. At least one of the numbers has to be 0. So what we're saying here is we can write down either x plus 2 equals 0 or x minus 3 equals 0. In order for this equation to be true, one of those bracket numbers has to have the answer 0. So we can split it up and say either x plus 2 equals 0 or x minus 3 equals 0. And the good news about that is it's just a wee mini equation. If we take away 2 from both sides, we end up with x equals negative 2. And if something take away 3 gives you 0, it has to be x equals 3 is the answer. And if you have a look, of course, we've already worked out that negative 2 and positive 3 are our answer, but we've worked it out using algebra. And so we can, I usually just get you to what the roots of the function, solution, and we just kind of put them x equals negative 2, x equals 3, a wee line in order to say, yep, this is my answer. And there we go. There we go. That's how you solve a quadratic equation. Okay, let's try another one. Solve the equation x squared minus 6x plus 5 equals 0. Okay, so this time it's given in an equation form. So if I turn that around and say, well, where did that equation come from? It comes from the function y equals x squared minus 6x plus 5, which looks like that. Oops. And what we're trying to do by solving the equation is saying at what points values of x is the y coordinate 0. Okay. At what points is the y coordinate 0? Well, we happen to know that the y coordinate is 0 when x is 1 and x is 5. So we're hoping with our algebra to be able to get the same answer. Okay, so just to remind, we'll not have, in future, we're not going to have the pictures. This is me just illustrating the fact that we know that we're connecting the equation to the function. Okay, so let's have a look at solving this equation. X squared minus 6x plus 5 equals 0. I'm just going to write that out again. X squared, x squared, I pressed the wrong button there. Let's start again. X squared minus 6x plus 5 equals 0. So we look on the left hand side and you see that's a trinomial expression. So we're going to have to factorize that. We know our answer is going to be in two brackets and we've got equals 0. It's really important to keep that. So what do? We can say, well, let's multiply. The first number is a 1, remember, 1x squared. 1 times 5 is 5. And then the number in the middle is negative 6. The coefficient of the x term is negative 6. That's what we're going to add to negative 6. Not a very good plus sign. So we're looking for factors of 5 that add to negative 6. So we're thinking, okay, 1 and 5 are our only factors, but 1 and 5 add to positive 6, which reminds us that if the sum is negative, we actually have to introduce, remember that two negative numbers multiply to a positive. So that, because the sum is negative, it means we have to introduce two minus signs here. Negative 1 times negative 5 is multiplied to positive 5 and add together to give us negative 6. There's a whole lot to remember about factorising, so go back and make sure that you can do that really well. And then we're going to put them in. You notice that it's a unitary x squared, 1x squared, so we can go right ahead and put x and x here, because x multiplied by x gives us our x squared term, and we can stick minus 1 and minus 5 in here. So the next part is to say if x minus 1 times x minus 5 multiply to 0, one of these numbers has to be 0. Okay, so we write down either x minus 1 is 0 or x minus 5 equals 0. What does that mean? We can solve that little equation, add 1 to both sides, we get x equals 1, add 5 to both sides, we get x equals 5, and sure enough, we get the same answer as we found in our graph. So the solution is the roots, or in this case, we're not asked for the roots, it just says solve the equation. So in this case here, the solution is just x equals 1 or x equals 5, and that is our solution. Okay. So you might want to go and practice that. I've got another couple of examples. If you want to stay with me, then that's great. Let's have a look at these two. So I haven't got any pictures now, so we're on our own, but also I've introduced a couple of examples where we have to use different types of factorising. So question 3 says solve the equation 4x squared plus 10x equals 0. So if you have a notice that there's only two terms there, and they both have x terms in them. So we can take a difference of two, not a difference, we can take a common factor. But also, not only is just x a common factor, but that 4 and 10 have a common factor of 2. So I'm going to take a common factor of 2x, and if I think about what is left in the bracket here, 2x times 2x gives me 4x squared, and 2x times positive 5 gives me plus 10x. So that's me done my common factors. Again, I can see 2x times 2x plus 5 multiplied together equals 0, so either the first number, which is 2x, has to be 0, or the second number, 2x plus 5, equals 0. Divide both of them by 2, we get x equals 0. And if we subtract 5 from both sides, we get 2x equals negative 5. And then divide each of them by 2, we get x equals, well, we don't actually have a whole number answer. X equals negative 5 over 2, or negative 2.5. And that's it. That's our answer. The solution is x equals negative, I always put mine in numerical order, but that's just me. It doesn't really matter. Starting with the smallest, you can see here. And I've also, so there we go. Now, the whole point of a solution is, of course, like anything, if we put either of those two answers in for x, substitute them in for x, we'll get 0. Okay? So the idea is of any solution for an equation is you're working out values of x which make the original equation true. And let's look at the last one here. It says find the roots of the function y equals x squared minus 9. So there's not an equation there, we have to rewrite it. That's basically us saying there's some kind of curve, a quadratic curve like that, and it cuts the x, there's an x-axis somewhere, although we don't know where. There's the x-axis, and we're wanting the roots of it. Remember, just like in the pictures we did before, we want these 2 points. What do we know about these 2 points? If that's the x-axis, then we know that, if that's the x-axis, we know that here and here, y equals 0. So we can rewrite it and say that roots exist when, okay, we take the right hand side, because we're basically saying we want that to be 0. So we say x squared minus 9 equals 0. Now this time on the left hand side, x squared minus 9, they're both squared terms, and there's a minus sign in between it. We've got a difference of 2 squares, which we haven't used yet. So remember how we factorise that. The square root of the x squared is x. The square root of 9 is 3. We put a minus sign and a plus sign in either order, it doesn't matter. And then we've got x plus 3 multiplied by x minus 3 equals 0. What does that say? It means that either x plus 3 equals 0 or x minus 3 equals 0, which means solving those equations we get x equals negative 3 or x equals positive 3. In other words, we know that the x coordinates here will be negative 3, and that one will be 3, so there's obviously a y-axis there. So our solution is x equals negative 3 and x equals positive 3. If you were asked for the coordinates, you would just put them in bracket form, negative 3, 0 and 3, 0. Okay, so that's how we solve quadratic equations. We need to set it up so that the right hand side is always 0. We have to factorise the left hand side and then split it up into a kind of either or situation, and then we solve these equations to get a solution. Hopefully that's helpful. Go and practice it. Let me know if you need any more help on it. Okay.